By now we know that the mass of an atom is expressed in atomic mass unit, and that atoms of elements differ in the number of protons, neutrons, and electrons they contain. Inside the lab, we need a unit that can be used for practical measurements. For this purpose, we use the unit mole, which can later be converted to grams. We express the mole by comparing the number of any particles to the number of atoms found in 12 grams of carbon-12 isotope. To understand the concept of moles, compare 1 kilogram of apples to 1 kilogram of oranges. While 1 kilogram of apples is equal to 1 kilogram of oranges in terms of the mass, we know that the number of oranges is not equal to the number of apples in 1 kilogram. The mole is the amount of particles, either atoms, molecules, or ions, that are there in 12 grams of carbon-12 isotope. This implies that the number of atoms in 1 mole of an element or molecule is exactly equal to the number of atoms in 12 grams of carbon-12 isotope. So we can say that 1 mole of sodium is equal to 1 mole of copper. Let's add another thing. The number of atoms in 1 mole of sodium is equal to the number of atoms in 1 mole of copper. Don't confuse it with the apple-orange example. We only used orange-apple analogy to highlight the difference between mass concept and the mole concept. We know that the molar mass of sodium is 22.99 grams per mole, meaning 1 mole of sodium contains 22.99 grams of sodium, and the molar mass of copper is 63.55 grams per mole. Even though 1 mole of sodium and 1 mole of copper contain an equal number of atoms, the individual masses of copper and sodium are different. So we said that 1 mole of any substance, whether it is a compound or an element, contains the same number of particles. So how many particles are there in 1 mole? Avogadro, around 1811, sought to explain Lewis's law, which states that the volume of two gases at the same pressure and temperature is the same. Avogadro proposed that for two gases to have the same volume, they must contain an equal number of moles. Later on, a British scientist, Joseph Lecky-Schmidt, used the kinetic theory and the measurements of gas molecules sizes to estimate the number of gas molecules. This led to the establishment of Avogadro's number, which states that there are approximately 6.022 by 10 to the power 23 molecules or atoms in 1 mole of a gas. Remember, most gases contain molecules rather than atoms. For example, oxygen, O2, hydrogen, H2, and carbon dioxide, CO2, are molecular gases. Only noble gases exist as individual atoms, such as with helium, argon, or krypton. Therefore, the correct statement is that 1 mole of carbon dioxide gas contains 6.022 by 10 to the power 23 molecules, and 1 mole of helium gas contains 6.022 by 10 to the power 23 atoms. We said that 1 mole of any substance is equivalent. Therefore, 1 mole of a gas is equal to 1 mole of carbon-12 isotope. Since 1 mole of a gas contains the Avogadro's number, we can say that 1 mole of carbon-12 isotope contains 6.022 by 10 to the power 23 atoms. Scientists established that 1 mole of the carbon-12 isotope has a mass of exactly 12 grams of carbon-12. Therefore, we can say that there are 6.022 by 10 to the power 23 carbon atoms in 12 grams of carbon-12 isotope. Back again to sodium copper example. We mentioned earlier that 1 mole of sodium is equal to 1 mole of copper, meaning they both contain the same number of atoms, which is approximately 6.022 by 10 to the power 23 atoms. However, it's important to note that 1 mole of sodium contains 22.99 grams of sodium, and 1 mole of copper contains 63.55 grams of copper. Notice that the molar mass we expressed earlier is the number of grams per mole.